All right, hello everyone. Welcome to my channel. This channel is designed for educational purposes, and we look at a lot of different, mostly esoteric and obscure theories of everything, all-encompassing theories, holistic um, gestalt theories that attempt to describe everything, cosmologies, and things that you can use in your own life. That can help you kind of organize your thoughts and all of your research and things that can, just benefit your life in general if you know about them. But very few people know about them because they have been actively suppressed by those good folks out there in our scientific establishment who are going to try to foist other stuff on you that agrees with their own paradigms, but usually doesn't produce results, or produces results but doesn't produce the actual concepts that are underlying. And so perhaps this channel doesn't agree with the trust the science mandates that are threats that are being thrown around out there all the time. But I believe it does follow science in terms of, what science is really about, the scientific method, the method of inquiry, of open, questioning, and, using observations and measurements to contribute to your understanding of things instead of suppressing and censoring these things so that you can fit your pet theory with a shoehorn into some kind of slot. So anyway, today is video number 340 that we are doing on the reciprocal system of theory from Mr. Dewey Bernard Larson. Mr. Larson lived from 1898 until 1990, and around 1930, he had some inspiration about the nature of the universe that he did research on and studied up on for the next 25, 30 years, came out with his two fundamental postulates in the late 1950s, and then took those postulates and derived a theoretical universe from them, and from that he wrote books kind of comparing his theoretical universe to that of the legacy scientists. That's what I would say Larson's biggest mistake was, or one of them, is that he trusted these scientists with his information, as opposed to probably what he should have done is he should have appealed to a general audience of intelligent, inquiring minds, as opposed to kind of spoiled, already know-it-all scientists who were completely closed to his new innovations and did everything that they could to discredit him in most cases. And as a result, Larson's theory is largely unknown today, except for a handful of people out there that are still kind of working on it. And the basic idea behind Larson's reciprocal system of theory is that he posits a universe that is made entirely of motion. And for Larson, motion was the relationship between space and time. And space and time have no independent existence. They only exist together in motion. You think of motion as a fraction, with time or space as the numerator and space or time as the denominator. Although space and time can come in multiple dimensions. That's what Larson refers to as coordinate space and coordinate time. both time and space are the same. They have the same general qualities. And so time we think of generally as being three-dimensional, or maybe 3 or 4-dimensional. And space too has that same quality, x, y, z coordinates, even though maybe we don't see that. And then what we generally know about time is that time is always getting later and later and later. It flows, or it progresses, and does so in a uniform manner, usually. Not unless there are very extreme circumstances, like very fast speeds. In the Newtonian world, it's a constant flow of time. And so space always has that, also has that same quality, which Larson refers to as clock time and clock space. Space is always getting farther and farther and farther apart. And in a constant flow. This is the flow of space. Now, this is a different kind of motion than what we generally understand motion as. Generally, we understand motion as a vector. It's a motion in a specific direction. But this kind of motion is a motion that lacks direction, lacks any type of specific direction. Really, it's just either in or out. And you kind of can visualize this using a balloon with dots on it. If you blow up the balloon, all of the dots are moving away from each other, but in no specific direction. They're all moving away from each one is moving away from each other one. The further away they're moving, the faster they're moving apart, the further away they're moving. I'm not sure which one is even right there. And that's the same as the clock time. And this was also observed in science by the Hubble telescope. All of the distant galaxies are moving away from each other. There's no specific motion until a specific direction, until you actually assign a reference point. Once you decide that one of those dots on the balloon is motionless, then you can impute directions to the motion. But if without assigning a reference point, there's no specific direction of the movement, and there's no even the areas, the places on the surface of the balloon that have no dots. Those are also moving away from each other too. So it's not even just the dots that are moving away from each other, but it's everything. It's really what you would call the progression of space. Space itself is moving apart. And so that's what Larson refers to as a scalar motion, a motion that has a magnitude, but it has no specific direction. And this is really the fundamental motion of Larson's system. And he points out other situations where scalar motion is also in effect, in addition to this stellar expansion, but also gravitation is another form of scalar motion, which is really the inverse of this progression that he's talking about. So the gravitation can be modeled using that same balloon, but you're sucking in the balloon instead of blowing it out. All of the locations and really the whole fabric of space itself is getting closer and closer together than in the case of gravitation. Okay, now other things, other caveats of this space-time or motion construct here. Not only do they have coordinate space and coordinate time, they have clock space and clock time. And both time and space come only in discrete units. There's a minimum unit of space and a minimum unit of time. If you don't have a full unit, then you don't have anything. And if you have one full unit of space in one full unit of time, you have the speed of light. which is basically for Larson is the background of this universe of motion. One of Larson's followers would talk about how, for thousands of years, space and time were thought of as being the container of the universe. This is the setting for which all other action of the universe is contained, like the stage of a drama. But in the reciprocal system, space and time themselves are the contents of the universe, not just the container, but also the contents of the universe. The things of the universe are also made of space and time, or together as motion. And so in a universe of motion, the first thing that you have is motion. That is this motion outward at the speed of light in all directions. At unit speed, Larson refers to as unit speed, 1 unit of space in 1 unit of time. And so this unit speed is the background speed, the null point or 0 point or reference point, origin, ether. And half of the universe is moving faster than the speed of light, which Larson refers to as the cosmic sector. And half of the universe is moving slower than the speed of light, which Larson refers to as the material sector, which is really the only of the 2 sectors that legacy science knows anything about. Evidenced by Einstein's dictum that the speed of light is the maximum speed of the universe. So he's actually ignoring 1/2 of Larson's whole universe, the cosmic sector. The cosmic sector is where, in the material sector, you have material atoms and particles and molecules. In the cosmic sector, you have cosmic atoms and particles and molecules. Maybe not so much particles, but we'll just say atoms and molecules. And these are called antimatter by the legacy scientists, but very little is known about them, and their origin is unknown to legacy science. Now, in Larson's system, when you cross this unit speed boundary, then you have to invert the roles of time and space, because the 2 sectors are reciprocals of one another. So basically, in the material sector, you have coordinate space and clock time. In the cosmic sector, you have coordinate time and clock space. And this shows that, among other things, that when you do cross into the cosmic sector, or when you cross that boundary, you have to flip or interchange the roles of time and space. Now, that's just a quick summary, and not a great one either, of Larson's first fundamental postulate and some of the consequences, but just a general overview of the reciprocal system. Now, what we're doing today is this is the second installment of reading an article from Dr. Bruce Peret, who is one of Larson's chief revisers at this point. Dr. Peret actually passed away about 3.5 years ago. But he took Larson's theory and revised some of the mistakes, or what he considered mistakes that Larson had made. Now, Larson admitted that he was subject to error. He believed that his theory was correct, but whether he applied it correctly was open to question, and that if he did make incorrect attributions and applications, that eventually it would become clear, and that other people would need to step up and make some corrections. And so Dr. Peret, along with Dr. KVK Nehru, both made great strides in correcting various aspects of Larson's theory. And they came up with something that they call RS2, the Reciprocal System 2, or the re-evaluation of Dewey Larson's work. And Peret has oh boy, the alarm is going off. No, Peret is, I'm sorry about this, but it goes off for a minute here. So anyway, Peret, he wrote about 10 different pieces here on the RS2. So this one is called RS2-101, and then he's got RS2-102 and RS2-103. And so we're going to take a look at several of these, if not all of them. And so today we're looking at RS2-101 part 2, because we started it yesterday, and it's called Creating a Theory. So this is kind of how he goes through from the beginning to create a theory. And he looks at both artificial reality and natural reality. Artificial law and natural law. The natural law is an observation about how nature behaves, whereas the artificial is a commandment about how you want nature to behave. And he shows how Larson, when he's getting it right, he's using more of a natural approach and observing how nature behaves and then aligning his theory to that. When he's using the artificial, then he can get in trouble. Okay, so here's part 2 of this article. It's called Dewey Larson's Artificial Reality, or this section. Dewey Larson was a chemical engineer, and his artificial reality, of course, was based on chemistry, namely observations of the periodicity of elements in nature, what we call the periodic table. He noticed that mass operated inversely to space through the concept of density, similar to the way time modifies space in the ratio of speed. However, the periodic table could not be explained with speeds unless this time denominator also had 3 dimensions, which was puzzling because time was always treated as a unidirectional scalar. While waiting at a stoplight, the thought hit him that space and time were just aspects of speed and possessed the same properties. If space was 3D, then time was 3D, and we only observed the net push of 3D time on space as a single scalar variable. Larson created an artificial reality to explain the structure of the periodic table using the concept of speeds, and devised the theory that later became known as the reciprocal system of physical theory. The reciprocal system of physical theory, that's the next section. Through the process of observing nature, Larson obtained enough information to construct a theory of a universe based on motion, a reciprocal relation of space to time. But unlike most theorists, rather than continuing on a deductive reasoning process, observing nature and constructing more man's laws, he switched to inductive reasoning to test his basic assumption of the reciprocal nature of space and time by creating 2 postulates that describe the observations made and the assumptions going in to the artificial reality he was defining as a theory. From these postulates, Larson was able to create a theoretical universe from natural consequences and compare it to what is observed in nature. His first postulate is an observation a natural law. The physical universe is composed of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Okay, that is the original version of Larson's first fundamental postulate. Now, over the years, he revised these postulates in small and sometimes a little bit larger ways. So, but this was his original first postulate. The physical universe is composed of one component, motion. Oh no, I'm sorry. This is not his first original. I'm not sure. This comes a little bit later, maybe around 1979 or 1980. This is not his original first postulate from 1959. I'm not sure why Peret has it in here without really labeling it. His paper, RS2-101b, kind of covers this. But for whatever reason, Peret is putting this one in here. The physical, first postulate, the physical universe is composed of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Larson observes that what is visible has 3 dimensions, height, weight, width, and depth, and both the content and container of the universe are a generalized form of speed, motion. In nature, change is the relation between content and container. And Larson observed that change can be defined by the mathematical concept we know as the reciprocal. Now, we look at Larson's second postulate, and Peret says his second postulate, okay, there are only 2 postulates, just to remind you. Okay, there's 2 postulates, the first and the second. His second postulate. Hello. I'm sorry about this video. Between the alarm clock and the Amber Alert that happened, I think we got bogged down, but unfortunately I don't have time to record another video right now, and I'd like to get this released, so we will have to start again at the end of where I got done, and we will be able to finish this tomorrow. I'm sorry for all the snafus happening today. I'm not sure. This Amber Alert that I got just kind of shut off my phone, and I don't have enough time to re-record the video. So we'll start again where we left off today when we resume tomorrow. Thanks for tuning in, and have a great day.